In this video, we're going to learn how to use the difference quotient. But before we can jump into the difference quotient, let's just go over a little bit more about function notation and how to substitute in things. So example 5 says, find the function f defined by f of x equals 5x squared plus 2x plus 1, and find the following values. So my first one is f of -3. So remember that is my x. So everywhere I see an x and I see 2, I see 1 here and I see 1 here, we need to replace that with -3. So this is 5 times -3 squared plus 2 times -3 plus 1. So now just simplify. You can put all of this in your calculator if you would like, or you can do it step by step. It does not matter which. I'll go ahead and get out my calculator. So 5 parentheses -3 close them squared plus 2 times -3 plus 1. And we get 40. Just like before, when I have something in parentheses, that's what I'm replacing my x with. I am now replacing my x with -x. So still where I see both of these x's, replace it with a -x. So now I have 5 times -x squared plus 2 times -x plus 1. Both of these x's get replaced with -x's. And now just do a little bit of simplifying here. -x squared, well, negative times negative is positive, so this becomes 5x squared. Positive 2 times a -x, positive times negative becomes negative, so this is a -2x. And then I can bring over my plus 1. Now I have no more like terms, or no like terms to begin with, and so that's my final answer. Notice on this one now I have the negative function of x. So exactly kind of what this looks like, I want a negative before my function. So this equals negative, and then write your function. 5x squared plus 2x plus 1. You can also think of this as a -1 times the function. And so we could do a -1 outside instead of just a negative. Either way, you're distributing that negative to all 3 terms, which changes the sign. So my positive 5x squared becomes -5x squared. My positive 2x becomes a -2x. And my positive 1 becomes a -1. As you can see here, even though these look very similar in notation, we get 2 different answers. The middle one here happens to be the same, but the squared, my x squared term and my constant have different signs, so they are different. And then on D, we have f of x plus h. What is in parentheses is still my x coordinate. So where I see these 2 x's, I am replacing it with x plus h. So this is 5 times x plus h squared plus 2 times x plus h, and then -1. I replaced both of these x's with x plus h. So now we have a little bit more simplifying to do on this one. This right here is a common mistake that's going to happen. A lot of times I see us just distributing, so to speak, this squared and make this x squared plus h squared, but we end up losing out on a whole middle term. So this right here, I'm going to bring over here. When you have x plus h quantity squared, what this means is I have two x plus h's. And now I have two binomials, and now we have two FOIL. So my first term is x times x, which is x squared. My outer term is x times h, which is xh. My inner is h times x, which is xh. And then my last, h times h, which is h squared. My middle terms, I can combine 1xh plus 1xh is 2xh's. Then I'll bring down my x squared and my h squared. And so this is just a little extra nugget over here. So now I have 5 times what we just found over here. X squared plus 2xh plus h squared. Now I can keep going. Now I need to distribute my 2. So 2x plus 2h, and then my plus 1 just comes down. And then my last step is to now distribute this 5 to all 3 terms. So I get equals 5x squared plus 10xh plus 5h squared, and then bring down my other 3 terms. And then that is simplified. I cannot combine anything else because there are no like terms to combine. Now for the difference quotient, we need to understand part D first and part C. If you do not understand how I got my answers on part D and part C, you need to rewind this video and rewatch how I solved those. We need both of these for the next portion. All right, so here is my difference quotient. And I don't know about you, but this right here looks like a really good test question. Just saying. My difference quotient is f of x plus h minus my function, and then it's all over h. So do you see what I mean when I say that this next portion here, you need to understand this because it's right here. And you need to understand this because it's right here. So we're going to do 3 examples of this. And this is a very big concept. This is actually how Calculus 1 begins, by finding, you'll set the limit as h approaches 0. And what this is going to find is derivatives. So we need to know how to use this formula here. So in my first part, I'm going to take this function here and replace wherever I see an x with x plus h. Now in this problem, I only have one x. So we've got 7 times x plus h plus 3. That is this portion right here. Where I saw an x, which is just right here, I replaced it with x plus h. Then I need to subtract my function. So I will do minus and then subtract this function here. And then it is all over h. So now we have some algebra to do. Let's simplify. I need to distribute my 7. So this becomes 7x plus 7h. I'm going to bring down my plus 3. And then I need to distribute this negative here. So minus 7x minus 3. And this is all over h. When you do this, there should be a lot of things that cancel. And on B and C, we're going to get more that cancels. But notice I have a 7x and a negative 7x. So those go away. I have a positive 3 and a negative 3. So those go away. So what I am left with is 7h in the top over h in the bottom. And h divided by h also cancels. And so this I'm left with 7. This one's not so bad when I only have 1. Now I have in B, and then when we get to C, I have to replace 2 of these x's with x minus h. Okay. So replace this x with x minus h, we get x plus h squared plus 3 times, in place of this x, I'm replacing it again with x plus h, and then bring down your plus 1. That is this portion here. So now I need to subtract my original function. So minus x squared plus 3x plus 1. And then once I do my f of x plus h minus my function, now this is all over h. Okay. So I'm going to slide this up now that I don't need that formula. So let's do some algebra and simplify. I have x plus h quantity squared. Remember, this is not x squared plus h squared. From that previous part, x plus h quantity squared is x squared plus 2xh plus h squared. You either need to memorize this or you're going to have to take it off to the side every time and FOIL that out. Plus, let's distribute our 3. Plus 3x plus 3h, bring down your plus 1. And then distribute here your negative. So this is negative x squared minus 3x minus 1. And this is all over h. All right, a lot of things should cancel here. I have a positive x squared and a negative x squared. Let's see, I also have a positive 3x and a negative 3x, and then a positive 1 and a negative 1. So on the top, I am left with 2xh plus h squared plus 3h all over h. When these cancel, everything's going to cancel basically that doesn't have an h with it, because when I get down to this next portion, notice how everything has an h. They all lose one of these h's. So this h goes away. You have h squared, so that means one h goes away. So I'm still left with the one h. This one goes away and this one goes away. So my final answer is 2x plus h plus 3. And you could put this all over 1, but we really don't need it. So this is my final answer. Let's try one more example. And I am going to make this one a little bit harder. And I'm going to do that by adding in a 4 right here. I want this to be 4x squared and then minus 2x plus 5. So I'm adding in a 4 to the original problem. I'm going to fold my sheet down so that we can see our formula from the top. Just folding my paper. And now let's go to work. So I have 2 x's again, and in place of 2 of these x's, I need to replace it with x plus h. So this becomes 4 times x plus h squared minus 2 times x plus h plus 5. That is this portion of my formula right here. Then I need to subtract my function. So minus 4x squared plus or minus 2x plus 5. And this is all over h. We know that x plus h quantity squared is x squared plus 2xh plus h squared, because we did that on the previous page. I'm going to distribute my 2. Which becomes minus 2x minus 2h. Bring down here plus 5. And then distribute your negative to all 3 terms here. So minus 4x squared plus 2x minus 5. And this is still all over h. Because I added a 4 here, we have that one additional step to distribute this 4 to all 3 of these terms. So this is 4x squared plus 8xh plus 4h. When I multiply 4 by these 3, this is what I get. And then nothing else in this equation is going to change, so I'm just going to bring it all down. And hopefully, everything without an h will cancel. All right. Positive 4x and a negative 4x. Negative 2x and a positive 2x. Positive 5 and negative 5. And so I am left with 8xh plus 4h squared minus 2h. This is all over h. Notice all 4 terms have at least one h. So they all lose one h. So when I lose one h here, my h's are gone. I have h squared. When I lose 1, I'm still left with 1 here. This one's gone and this one's gone. So my final answer is 8x plus 4h minus 2. And again, we could put that all over 1, but that's not necessary.